Hello friends and welcome to She Tech Education YouTube video channel. In today's lecture we are going to discuss regarding torques in epicyclic gear train. In previous lectures we have studied what is gear train, what are different types of gear trains, what is differential gearbox. We have solved problems based on epicyclic gear train and differential gearbox by using tabular method. Now, if suppose in such a gear trains or particularly in epicyclic gear train, if suppose input torque is given, how to find out output torque, or if suppose output torque is given, how we can find out input torques, that things we will discuss in today's lecture. Now, consider a diagram in that right corner. It represents the epicyclic gear train. That means first member is any one of the gear, middle member we will consider it as a fixing member, and last member is another gear. That means in general in epicyclic gear train three gears are there, that is input gear and output gear and the member joining these two gears by which it can rotate about some another axis, that is arm. Now some things we are fixing in that epicyclic gear train. Now we will consider here as a input gear, output gear and one fixing member. Same thing I have considered in that diagram. Now the input shaft or driving shaft has given a torque tau 1 or T1. Output shaft or driven shaft has undergone the torque T2. Now torque required to fix that middle member I have considered as a tau 3. Now there are three torques under equilibrium condition externally applied for this gear train. First torque is input torque or driving torque as a T1, output torque or resisting torque or load torque on the driven member as a T2, holding torque or braking torque or fixing torque on a fixed member as a tau 3 or T3. Now the net torque applied to this gear train must be 0. That is T1 plus T2 plus T3 is equal to 0. That I can write because this whole gearbox or this whole gear train is under equilibrium condition. That's why the summation of all torques is equal to 0. Now same thing I can write, same equation 1 I can write as F1R1 plus F2R2 plus F3R3, that is torque tau 1 I have written as a product of F1 into R1, that is F1, F2, F3 are the corresponding externally applied forces at radius R1, R2 and R3 in the three members. Second equation, consider it as a second equation. Now if omega 1, omega 2 and omega 3 are the angular speed of driving, driven and fixed members respectively, and the friction is neglected, then the kinetic energy dissipated by the gear train must be 0, isn't it? Now this kinetic energy I can write as a tau 1 into omega 1. Similarly for all members, tau 1 omega 1 plus tau 2 omega 2 plus tau 3 omega 3 is equal to 0. This summation of all kinetic energies, net kinetic energy will be 0. Now if omega 1 is the input angular speed, omega 2 is output angular speed, omega 3 is angular speed of fixing member, which will be equal to 0 because there will be no speed if we have fixed that fixing member. Therefore that third equation will become now tau 1 omega 1 plus tau 2 omega 2 is equal to 0. Now underline that equation 4, tau 1 omega 1 plus tau 2 omega 2, that is nothing but it is a product of torque developed by motor or input torque into angular velocity or angular speed of input torque plus torque developed at output shaft into angular speed of output shaft. Now note that if this omega 1 and omega 2, that is angular velocity of input shaft and output shaft, are in same direction, then these torques tau 1 and tau 2, that is input torque and output torque, are in the opposite direction. And if reverse case, if I consider that is omega 1 and omega 2 are in the opposite direction, then tau 1 and tau 2 will be in the same direction. That is, now here in this case, consider that omega 1 and omega 2 are in the same direction. In that diagram also I have shown these two gears are rotating in the same direction. Then tau 1 and tau 2 will be in opposite direction. That is, if tau 1 is positive, tau 2 will be negative. In that fourth equation, if tau 2 is negative, I can shift that tau 2 into omega 2 term in right hand side. Then I will get a term, whatever I have written at the last in the square bracket in red color, that is tau 1 omega 1 is equal to tau 2 omega 2, that is torque developed by motor if motor is input into angular speed of motor is equal to torque exerted on the machine shaft, that is output shaft, into angular speed of the machine shaft. Remember this equation, that is tau 1 omega 1 is equal to tau 2 omega 2 for further calculations. From that, tau 1 is input torque, tau 2 is output torque, omega 1 is in angular velocity of input gear, omega 2 is angular velocity of output gear. Now if you want to calculate the tau 3 torque, that is torque required for the fixing member, or torque that is also called as the braking torque or holding torque, if you want to find out that tau 3, we can find out from equation first. Because tau 1 and tau 2 are known, tau 3 you can find out that as tau 3 is equal to minus tau 1 minus tau 2, isn't it? Now tau 1 and tau 2 just you can find out from this last square bracket equation. Now based on this we will solve one problem, because previously in previous videos we have solved problem based on epicyclic gear train by tabular methods. Now just further extension of that problem is based on this finding of torques, input torque, output torque, or holding torque. Now we will solve one problem. Figure shows an epicyclic gear train. Pinion A has 15 teeth and it is rigidly fixed to the motor shaft. Now from this sentence we can get that pinion A has a 15 teeth and it is connected to motor shaft, that is it is an input shaft, or gear A is input gear. The wheel B has a 20 teeth, P has a 20 teeth, and gears with A and also with the annular fixed wheel E. Observe that sentence, annular fixed wheel E, that means gear E is fixed. One condition while solving problem it is given in that sentence, NE is equal to 0. First stop, the pinion C has 15 teeth, TC is equal to 15, it is also given, and in integral with, it is integral with the gear B, that C gear is integral with P, that means B and C are compound wheels or compound gears. The speed of gear B will be equal to speed of gear C. Full stop. Gear C meshes with the annular wheel D, which is keyed to the machine shaft. That means this gear C is our output shaft. This, observe that sentence carefully. Gear C meshes with annular wheel D, which is keyed to the machine shaft. That means gear D is output shaft, which is connected to machine shaft. The arm rotates about the same shaft on which A is fixed. This arm is rotating about gear A and carries a compound wheel BC. If the motor runs at a 1000 rpm, that means input gear A rotates with 1000 rpm, that is Na is equal to 1000 rpm, it is given condition. Find the speed of machine shaft, that is speed of output shaft Nd is asked. If the motor develops a torque of 100 Newton meter, torque exerted on output shaft, that is tau 2 or tau d, is asked if input torque, that is tau a, 100 Newton meter is given. Now for solving this problem, we know that we have one formula, that tau 1 omega 1 is equal to tau 2 omega 2 if omega 1 and omega 2 are in the same direction. Now in that formula we are having unknown tau 1, that is input torque, it is given as 100 Newton. Omega 1, that is angular speed, omega 1, instead of omega 1 we can directly write n1 as well, tau 1 n1 is equal to tau 2 n2. Now n1, that is input gear speed, that input gear is a gear whose speed is given 1000 rpm. Next is equal to tau 2 omega 2. Now tau 2 is asked to find out, and omega 2 is not given, that we have to find out, that is n2, that is speed of output gear, and output gear is d gear, nd. That means this problem we have to solve as usual by tabular method to find out speed of gear d first, and then we will find out torque acting on that. So let us start. Now number of teeth on A gear, B gear, C gear are given. D gear and E gear are not given. That we will find out from the geometry of the figure. From geometry of the figure I can write the relationships for the diameters of all gears. Now for the gear diameter E, diameter of gear E is equal to diameter of gear A plus 2 times of diameter of gear B. Isn't it? Observe that carefully. After observing you can judge that this diameter of gear E is equal to diameter of gear A plus 2 times of diameter of gear B. And for diameter of gear D, diameter of gear E minus the diameter of gear B minus DC, or diameter of gear C. This is the equation got from geometry of the figure in terms of diameters. These equation directly I can convert into number of teeth because their pitch circle diameters are same. The theory behind that we have discussed in previous lectures as well. Therefore directly I will convert these in terms of number of teeth. From that TE and TD are not known, other number of teeth are known. From that we can find out by simple calculation. TE is equal to 55, TD is equal to 50. Now after finding teeth, we will prepare a table by a tabular method. As usual, apply 4 conditions to all elements. Now this condition I will write first. 4 conditions are there. Then revolutions of each element. How many elements are there in this gear train? First, as usual, write down arm. Secondly, write down the gear to which we are providing plus 1 revolution. Now here to gear A I will provide a plus 1 revolution. That's why I will write A gear after arm. Then to A gear, which gear is connected? B gear is connected, and B and C are compound gear. That's why I will write out in the same column. That's why third column will be of compound gear BC, B and C. Now B gear is connected to E gear. Sorry, before that I have written C gear is connected to D gear. That's why after compound gear BC I will write will D, and then B gear is connected to E gear. That's why I will write down gear E. Now this will D and will E I can shuffle as well. That means first I can write E gear and then gear D. There will be no any problem. Now I have written all the elements. Now I will apply the condition. Fix the arm and give plus 1 revolution to gear A. This is my first condition. Apply to all. Fix the arm, that means arm will be revolution will be 0. Gear A revolution will be plus 1 because I have given 1 revolution anti-clockwise. Now next, A gear is in mesh with B. Therefore, the revolutions of this compound gear BC, to find out this, I will use a velocity ratio between gear A and B because A gear is in mesh with B. Therefore, see that calculation, first calculation I have written there in upward side. Velocity ratio of gear A and B is equal to NA upon NB is equal to, in terms of teeth, TB upon TA. Now NB I can find out NA into TA upon TB, but NA is speed of gear A is +1, that's why NB is equal to TA upon TB I have got. But in that table I have written it as a minus TA upon TB. Now why I have to take a minus sign? Because if gear A is rotating with +1 revolution, that is anti-clockwise, gear B will rotate in opposite direction of that A gear because these are externally meshed gears. B gear will rotate in opposite direction, that means with a minus sign, that is clockwise direction. That's why I have given minus sign to the speed of gear BC in the table. Next, now this BC are the compound gear, that's why velocity of B, whatever speed of B gear is there, same will be for the speed of gear C because these are compound gear. Now next, in column of wheel D, again that speed I can find out by using velocity ratio to T gear. Which gear is in mesh? C gear is in mesh with D, that's why I apply velocity ratio between gear C and D. Observe that second calculation in the top side. Second calculation, velocity ratio between C and D is equal to velocity of driver gear divided by velocity of driven, that is NC upon ND, is equal to reciprocal of that TD in terms of teeth, TD upon TC. I am finding ND. ND is equal to NC into TC upon TD, where NC is equal to NB, and what is NB? NB is TA upon TB. Therefore ND I have got TA upon TB into TC upon TD. Again, now C gear is in mesh with D. C gear is rotating with minus sign, and D gear will rotate again in the same sign because C and D gears are meshing internally. Whenever gears are meshing internally, they will rotate in the same direction. That's why again minus sign will be there for the velocity of gear D in that first condition. Now observe that I am doing calculation in the top side, but I am not taking any sign of the velocities during calculation. I am writing the sign only in the tables. Remember this thing. Now third, for wheel E, what will be velocity, that I will find out by again calculation. Third calculation in the top I have written there. Velocity ratio between gear B and E is equal to NB upon NE is equal to, in terms of TA upon TB. Therefore NE I can get is equal to NB into TB upon TE, where NB is equal to TA upon TB. Now don't consider here NB is equal to minus TA upon TB because minus sign only I will consider while writing in the table. During calculation NB only consider that value TA upon TB. Put that value of NB, I will get NE is equal to TA upon TB into TB upon TE, where TB will cancel, remaining TA upon TE. Now for giving sign to gear gear E gear is in mesh with gear B. B gear is rotating with negative sign. Therefore E gear will also rotate in negative sign because in the same direction, because gear E and B gear are meshing internally. That's why there will be negative sign. This is the first condition I apply to all elements. Now apply second condition. Now once first condition is found, next table, preparing the table is very easy. In second condition you are multiplying to all element by to equation first by x, that is fix the arm and give plus x revolution to gear A. Same condition as that of first, but in second condition we are giving plus x revolution to A. Therefore multiply to that first condition by x, you will get the second condition. In third condition, add plus y revolution to all element. To all element I have added a plus y revolution, given a plus y revolution. This is third condition. Fourth condition, total motion of all element, that is the addition of second condition and third condition will be there at the bottommost row, that is total motion. Add a second and third condition for arm, that is 0 plus y, it will be plus y. For pinion A, add a second and third condition for getting fourth motion of total motion, that is x plus y. For compound gear BC, minus x into T upon TB plus y. Same thing I have written, y minus x into T upon TB. For gear D also, for gear E also, add second and third condition and write in the fourth condition. At the bottommost row, whatever I have got, these are the formulas for revolution of each element in the epicyclic gear train. These are very important formulas for solving the problem. Now next, two conditions must be given in the problem to solve this problem, this type of problem, and these conditions in this problem are: the speed of pinion A is 1000 rpm, it is given. What is the formula for pinion A? We have got as x plus y, last row, x plus y. Therefore x plus y is equal to 1000. This is equation 1. Also we have given that annular wheel E is fixed. What is formula for annular wheel E? Last row, y minus x into Ta upon T is equal to now 0 because it is fixed. Now this is second equation. Now solving first and second equation, we will get value of x and y. Now these values of x and y we have to put in the formula whatever we have asked in this problem. Now we have asked to find out torque of output gear. What is output gear? Output gear is D. That's why we are finding speed of that gear D. What is the formula for speed of gear D? It is y minus x into T upon TB into TC upon TD. In that formula, put the values of teeths, put the values of x and y and find out ND speed. I have got that ND speed as a 37.15. Do this calculation afterwards by pausing the video. Next, we are after finding speed, we have to find out the torque exerted on the machine shaft. The torque we can find out as, again, observe carefully, input shaft is on input shaft A gear is mounted which is rotating 1000 rpm, it is having plus sign. Observe carefully, ND is output shaft which is rotating with again plus sign, that means anti-clockwise only. That means input gear and output gear have the same sign, that's why torque will rotate in opposite direction. That's why whatever equation we have written previously here, it is correct. It is applicable for your problem. That is torque developed by motor into, that is tau 1 into omega 1 is equal to tau 2 into omega 2. If these omega 1 and omega 2 are not in the same direction, you have to write as a tau 1 omega 1 is equal to minus tau 2 omega 2, isn't it? Now here it will be tau 1 omega 1 is equal to tau 2 omega 2. And what is tau 1? Torque on A gear, that is 100 into what is omega 1? It is omega A, that is angular speed of A gear is equal to torque exerted on the machine shaft, that is our torque output, into omega D. Now write down, instead of omega A, directly you can write out NA because omega is equal to 2 pi n by 60, 2 pi and 60 will get cancelled, NA and ND directly you can write, and we will find out the torque tau 2 as 2692 Newton meter. This is your problem to find out output torque. Now in this same problem, if suppose a holding torque has been asked, that is tau 3 has been asked, what you can do? You can do tau 3 is equal to tau 2 minus tau 1. Sorry, minus tau 1 minus tau 2. By using that formula, you can find out the holding torque as well. Now thanks for watching. For next further videos, Stay tuned with this YouTube channel, Shri Tech Education. Thank you.